Okay, you need to have your exponent rules booklet. Okay, you should have your name and exponent rules written on the front. Okay, so this was the one I've been working on. If you would, turn in your booklet to the second page there where we had the P, the M, and the A. And we discussed this yesterday, and this was not a rule that we talked about yesterday, but it lends itself to the multiply the product of powers rule here. So we did go ahead and include it in our foldables. So you already have one of the two things we're going to talk about today. But power to a power indicates you have one base with an exponent raised to another exponent. And so basically if you have exponents side by side as you do in this example, you would multiply them, which is why it lended itself to the next part of our foldable here. So power to a power rule, what you need to remember is you're going to multiply. Now this rule is not generally seen by itself. It's actually going to be with the next one we're going to discuss. So if you would, leave this page blank. We're not going to get to that one just yet. Flip to the last two pages in your booklet. And across the top, you may want to center yours more than I have mine, but across the top of your booklet here, write similar to the distributive property. Now that you have this written, okay, and this is going to go for both sides of this booklet, but we're only going to focus on one thing today. The only one that we're going to talk about is product to a power. Now, this is where you will see the power to a power rule most often, is when it's within this product to a power. Now, I'm going to give you actually the general form for this, and then we'll discuss maybe a couple examples. But we have the product of A and B. So there's your product part of your name of your rule there. The product of A and B raised to the second power. Basically, like it says up here at the top, it's similar to the distributive property, because what you're going to do, I'm going to write this step in here so you can see this, is you're going to take the 2, that exponent, and you're going to make sure that A gets raised to the second power, and you're going to make sure that the B is raised to the second power. So you can have A squared B squared. So it's pretty simple, really. You just make sure that everything within the parenthesis is raised to that exponent. Now if there's anything outside the parenthesis, it does not get the exponent, so you have to be very careful with that. So an example of this, let's look at an example. We're going to do something maybe a couple of these. We'll call this example 1. 3k to the 4th to the 4th. Now, just like we did up here, we want to make sure, I'll do this maybe in a different color in green to show the distributive property. We want to make sure that 3 is raised to the 4th power, and then we also want k to the 4th power. So this is where we have to be very careful. I'm going to write out this step, and this is what it's going to look like, kind of using this. We're going to have 3 raised to the 4th power, and then we're going to have k to the 4th to the 4th. So I just took each piece in here and raised it to the 4th power. So now this is just something simple that you can use either your calculator, or if you know what 3 to the 4th power is, you should be able to do this really without a calculator. 3 to the 4th power is 3 times 3 times 3 times 3. 3 times 3 is 9. That's 2 of your 3's. 3 times 3 is 9. That's the other 2 of your 3's. 9 times 9 is 81. So that's one way you could simplify that. But 3 to the 4th is going to be 81. And then here's your power to a power rule. When you have a one base with an exponent raised to an exponent, you're going to multiply these. So you multiply your 4 times your 4. So we have k to the 16th. And that's your answer. So raise everything in here to this exponent here, and then simplify based on other exponential rules. Alright, so let's look at another example of this. We'll put 3 in here. We'll do 2 of these, and then we'll put one of them that is scientific notation. So this one is going to be a little more detailed. 2x to the 4th, y to the negative 3rd, all to the negative 2nd power. Alright, so again, we're going to distribute. We have 3 things in here. We have a 2, we have an x to the 4th, and we have a y to the negative 3rd. And we have to make sure all 3 of those are raised to the negative 2nd power. So it's going to look like this. 2 to the negative 2nd, x to the 4th to the negative 2nd power, and y to the negative 3rd to the negative 2nd. Alright, now I'm going to kind of work this one a little bit differently. Up here I went ahead and multiplied, did the 3 to the 4th because I knew I would get this number here, but I'm going to wait on this one. And you're going to see here in just a minute why I'm going to wait on this one. I am going to go ahead and remove the parentheses, but this is going to give me 2 to the negative 2. Now if you type that in your calculator, you are going to get a fraction. And we are going to wind up with fractions here because we are going to wind up with negative exponents, and remember that rule, cross the line, change the sign. So I'm going to leave this as a negative exponent for now so that I can make sure this gets moved to the correct spot in my final answer. These I can go ahead and use the power to a power rule. So if I do that, this would be x to the negative 8, because 4 times negative 2 is negative 8. Power to a power rule again here. Y negative 3 times negative 2 is 6. So again, to kind of recap, this is an even, or I mean a positive exponent. So I went ahead and simplified that. Positive exponents make things pretty easy. But when you have negative exponents, you need to be alert and aware that things are going to start moving. And so you don't want to type this in your calculator. You want to wait and make sure you move this to where it needs to be. So if it's positive, go ahead and simplify it. If it's negative, let's kind of hold off and make sure we know what we're doing. So this is what we've got. We've got 2 to the negative 2, x to the negative 8, and y to the positive 6th. If you think about the rule, cross the line, change the sign. Here's our fraction. We've got to think about what's going to cross the line. Well, right now, only negatives cross lines. That's what the rule is. Well, 2 to the negative 2, negative exponents, excuse me, it doesn't matter about the coefficients, but this is 2 raised to the negative 2. This 2 has a negative exponent, so that means it's got to cross the line, and its sign is going to change. This x has a negative 8, so this x has a negative exponent, so this also has to cross the line and change the sign. Now the y does not have a negative exponent. That turned out nicely because a negative times a negative gave us a positive. So y to the 6th is going to remain in the numerator. Now you're almost finished here. You want to go ahead, now that I do have a positive exponent on that 2, go ahead and simplify. Y to the 6th over 2 squared is 4, x to the 8th. That's your final answer. So always be very, very careful with your negative exponents. Last example that we're going to look at deals with scientific notation. So 8.9 times 10 to the 5th raised to the 4th. So same rules that we've been using. We're going to take 8.9 and we're going to raise it to the 4th times 10 to the 5th raised to the 4th. Just looks a little bit different because we're in scientific notation, but same rules apply here. So you may want to get a calculator out in order to simplify 8.9 times, or 8.9 to the fourth power. So 8.9 raised to the fourth power gives us, and we're going to go ahead and we're going to round this. We're going to do 6274, so 6,274.22. So 6,274.22 times, and then here, power to a power rule, 5 times 4 gives us 20, so 10 to the 20th. Now we need to think, if I were going to write this in correct scientific notation, this decimal point is not in the right spot because this number has to be between 1 and 10. Okay, so we're going to have to move this decimal point this way, in this direction. So we're going to have to move it 1, 2, 3 times. So this is going to look like this after we move it 3 times. 6.27422 times, but now because we've moved this decimal point, if you remember, if you can recall, that does affect our exponent now. I moved it 3 more times away from where it was originally, so that's going to be 23 now. We have to add that 3 to our 20. So scientific notation follow the same rules, but just be very careful because you are going to have to move your decimal point in a lot of cases to put your final answer in correct scientific notation in the end. We will finish up your foldable this week, so make sure you have all these notes on power to a power and product to a power.